Hey guys, in this tutorial we're going to be looking at how to create something like this. The logic behind this is really quite simple actually. We'll just take a look at it in Rhino. So all it is, we started with a circle, we rotated some planes around that circle, and then we divided those planes up, basically connected up the geometry to create this. Alright, so we're going to dive into a new document and let's get started. So we're going to start with that circle that I talked about. We're going to give it a radius. I'll set this to a maximum value of 100. Plug that in, bump it right up, and we're going to do some perpendicular frames along that curve. Now these planes are all facing they're all facing inwards at the moment, but what we want to do is we want to rotate those planes around a little bit. So we're going to use the rotate plane component. We're going to plug our plane or our frame into there, and our angle is going to come from a range component. My range is always going to be a multiplier of pi, so I'm going to drop down a slider, make it an integer slider, make it up to 10, not 100, and we're going to drop down an expression which is going to be 2 times pi times x, and we're going to drop that in, get rid of our y because that's not necessary, and that's our domain. And then our steps is going to come from this slider. I'm going to bump this up to something like 50. Actually, you know what, make it a nice binary number like 32. And we'll plug that into here and here. Now, as always, when we plug a number into our range, it is going to give the number of list items is going to be that number plus 1. And you'd think the same would happen for our perpendicular frames, except this is the one exception to that rule. The exception is the closed curve. If the curve is closed, then it will create that exact number of frames. Now let me just quickly explain that. If I drop this curve down and plug that into here, we're going to get 14 frames because we need to create 13 divisions. Let me just drop this down actually to 3. So we have 1, 2, 3 divisions in here. But if we have a closed curve, we don't need that extra plane because the first plane creates that last division as well. So we now have 1, 2, 3 divisions with only 3 planes. Alright, so there we go. So what we need to do is we need to drop down a cull index over here, set our integer to -1 because we want to cull the last item in there, and this will give us a matching data structure. And now I'm just going to bump this up to maybe I only want it at around 16 for now. Turn our circle off, and oh right, we're not rotating because we had 0 times 2 pi x over there. Alright, so we'll preview off those frames, and there we go. Now what we also want to do is we want to create a rectangle. Let me see. Oops. Create a rectangle on a plane. Okay. So my domain for this, we're going to construct a domain. Plug that into our x and y. Grab a negative value, and we're going to copy this slider over here just because it's easier. Drop that in, and 100 is way too big for this plane. I'm probably only going to set this to a maximum value of 20 or so. And then I'm going to use the orient component. The orient component takes some piece of geometry as the input, an initial plane which is our world XY, and because we're creating this on the world XY plane, we do not need to plug anything into that initial plane, but we are going to plug in our rotated planes. And actually, before I do that, I am going to turn these all into surfaces. So we'll plug those in there, and that's our initial piece of geometry. Alright, so there we go. Next, we're going to divide up the surface, and we're going to drop down another slider, set this one to a maximum value of 10, make it an integer slider, plug it into my U and V, and I'll set it to 4 for now. Alright, and so next we need to create some sort of geometry on each of these points. In fact, actually no, I don't want a surface divide, I want a surface frames component. I'm going to plug my surfaces in there, and then plug in my U and V, because we want to use these plane pieces of geometry as the starting point for the next step. Alright. Now we're going to drop down some center boxes. I'm going to plug those in there, and then I'm just going to plug in the slider for my X, Y, and Z size. Let's see, X, Y, and Z. And actually, no, I don't want to use actual boxes like this. What I do want to use, okay, I'll still keep this box here, but I'm going to turn them into mesh boxes. The reason I'm using mesh boxes as to what's your standard B-rep box is that these are a lot heavier in terms of geometry calculation. We want to keep this nice and simple because this could get quite complicated. Alright, I don't want very many divisions on my mesh box. In fact, I probably won't even go above 1. We'll just keep that there. So the mesh box takes an original box as an input and just turns it into a mesh box. So we could subdivide it if we wanted to, but we are not going to. I'm going to keep it at 1. And then we're going to orient again. So we're going to orient our piece of geometry to each of our planes. Oh, sorry, to each of our planes, not from each of our planes. And we'll just change that size a bit. Turn these off. And I'll turn this mesh box off here as well. Alright, so that is the basic way this definition works, without getting into the complexity of it. But obviously, in order to create the next part, things are going to get a bit complex. So let's drop down a we're going to use a relative item. I'm not sure if I've explained this at any point yet, but I came across this great technique from XLab. They did a Grasshopper tutorial series on Vimeo back when I was learning, and I came across this fantastic technique. I'll show you how it works. So if I drop down a sphere and plug that into, oh sorry, no, that's not what I want to do at all. I want to divide this sphere up using a divide surface, if I can hit the right function. And then I'm going to plug in an amount of divisions. And I also need to change this to an integer slider. Alright, now I'm just going to make this have a bit larger of a radius. 20 is probably still a bit small. Plug in this one that goes up to 100, and I'm just going to preview these off for now. Alright, so I've divided up my surface into 10 points in each direction. I'm going to simplify this output, and I'm also going to graft the output. And then we're going to plug this into our tree to operate on here. And so the offset basically relies on a path index input. So what I'm going to do is I'm going to drop down a panel, and I'm going to look at I'm going to start by just typing in a 0, 0 for my panel, and so I'm going to plug that into my offset. And actually it's not going to do anything at the moment. Actually I put the wrong kind of curly brace in there. Alright, there we go. So it's not going to do anything at the moment, it's just going to return every point out of this B input. But what we could do is we could add to this structure. So if I wanted to offset this in any direction, I could go 0, 1. And then this will give me 2 items here. And what this will basically do is this will give me item 0, 0 and item 0, 1. So if I were to create a polyline through these, plug that in, that's going to connect each point with its neighbor. I could change this to 1, 1. And then this would create this cool sort of twisting pattern going around the sphere. If we wanted, we could try and create maybe like a diamond sort of pattern. Well, actually, let's see what we can create. We'll go 0, 0, 0, 1, 1, 1. This will probably create a square, and then 1, 0. And there we go. This is creating quads. And so, sorry, one sec. So what we can also do in order to understand what's going on here is we can use a text tag. Oops, I'll use a text tag 3D. So my location is going to be each of these points, and the text to display what I am going to display. So I'm going to display each and every one of these path indices. So I'm going to get a tree statistics component. I'm going to plug that in, and a key thing to note with this tree statistics component is it flattens your data structure. So this path output here will just be a flat list of paths. So if we do want to plug this in, we need to graft it, and then that is our text. And then we just need a size parameter. Set that to a value of 10. Plug that into my size, and there we go. So now I just want to turn these points off. I want to turn those points off as well. And so now we can see how we need to match data up. So if I did want to create a diamond panel, I would need to, let's say we started at 8, 9. We would need to go to 9, 8, then to 8, 7, then to 7, 8, then back to 8, 9. So we'll just make a copy of this path here. And so if 8, 9 will become 0, 0, and then we're going 1 across and 1 down. So we go 1, minus 1, and then for the next one we go 0, minus 2. Should note that this is always relative to the first number. Okay, and then third one is, what's that? That'll be minus 1, minus 1. And then plug that into our offset. And there we go. We have created all these diamond panels along our surface. Now you'll notice that this polyline is also throwing an error It tells us there are insufficient points for a polyline. You might be wondering why that is, because it looks like I'm creating a full set of diamonds around there. But if we look over here, what's coming out of our B input, you'll see that some of these items only have 1, 2, or 3 items in them, as opposed to the 4 inputs that we plugged in. And this is because when a path if we were to go to 0, 0 and try go -1, it doesn't know what to do, so it stops over there. We do have the option, the option to wrap the paths around, but that might create some unwanted items there, which is why I don't tend to use that. So what we can do is we can just use a prune tree component over here, and we can prune anything with less than 4 items, and there we go. We get a purely healthy looking polyline component. Alright, so that was a bit of a detour, but I'll post a link to the to the tutorial that I learned that from, because just in case they show anything that I don't show. But we're going to use that exact same sort of principle here. So we have all these oriented pieces of geometry, and we're going to look at our data structure. We're going to actually simplify that so we can tell what's going on. Looks like we've got a 3-dimensional data structure, which makes sense because we've got cubes in this direction, we've got cubes in this direction, and then we've got planes in this direction with cubes in each direction on there. So what I do want to do is, let me see, I want to start by grafting these inputs. And so what we're going to try and do, actually no, I don't want to graph those just yet, because what I want to do is I want to be able to connect, say, this face over here to this face over here. So what we're going to do is we are going to explode these meshes. And as soon as we explode that, we're going to get one more layer to our data structure. So now we've got a 4-dimensional data structure, which might absolutely blow your mind. Might not, who cares. And what we're also going to do is we're going to get a face normals component, and we are going to drop down a point list. I'm just going to turn those off. And so what you should be able to see, oh, hold on, what's gone wrong? It looks like the face normals has put a graph somewhere in between here, so what we do want to do is just shift the paths before after it grafts it, because we don't seem to have an option to not do that. And so we'll just preview this off, and so what we should get is our face index numbers. So this is face 0, 1, 2, 3, 4, 5, and so we're going to start by trying to connect these up. So from my shifted path data, actually no, I don't need to do that. We need the grafted items in order to work with our relative item. Oops, not relative difference. Relative item. Nope, not that one either. Relative, third time lucky. Relative item. So we're going to take each of our center points and need to come up with an offset. So let's see. Our offset, because, okay, so the first thing we need to note is we're going to go from one tree to the next tree. We're going to create this link first. So the way I can quite easily tell which direction that is in is that I know that I plugged in 16 numbers for that direction. So what we want to do is we want to connect, let's go 0, 0, 0, 0 up with let me see, let me actually plug in this one. And we want to connect that to 1, 0, 0, 0. Okay, so this will firstly create. Actually, I'll join these up with the polyline so we can see what's going on. And it doesn't look like much is going on at the moment. Did we create any polylines out of that? No, we did not. Ah, right, I need to turn my multi-line data on. Okay, so there we go. So it looks like it is connecting the wrong faces to each other. So now we need to check which faces we want to connect. I'm going to turn off my relative item, and I can see that I want to connect face 0 up with face 5. So 0, 5, let's make sure we've done that. Nope, we've done it in the wrong way. We need to connect 0, 0, 0, 5 with 1, 0. Okay, there we go. What I'm also going to do at this stage is I am going to wrap the paths because it's not giving me that final one. So I'm going to invert this pattern, and now we just need to find which one of these is the one we want. And actually, before we wrap the paths, we can check that in here. So we can see every time we get 2 points in a list, we want to keep that item. So it looks like we're keeping every 6th item. So what I'm going to do is I'm going to create a cull pattern. And I'm going to take from this flattened list, I'm going to invert that. So that's my list. And let's see, I want to, sorry, wait, why did I create a slider? I want to make a list, and I want to go true, true, sorry, not true again, true, false, 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 false. So 5 falses and 1 true should give us the correct items that we want. Alright, so we've made that connection. Now we need to make the next connection, which is going to be this face here with this face here. So this time we know that we're not sort of transcending across these how shall we say, these planes. Oops. So I'm gonna make a copy of this, and this time, okay, I'll just turn this off, preview this back on, turn off my wrap paths, and so we know that we're not going outside this first point of data structure, but it'll be in between these points, or in between the middle indices. So we're going to go, let's see, we need to go from face 4 to face 2. So we'll go 0, 0, 0, 2, oops, to 0, 1, 0, 4. And see what happens there. And you know what? That kind of looks like it worked, except that any other number that fell into that range has also been accommodated for. So what we do need to do is we need another cull pattern. Actually, instead of flattening this here, actually I will flatten that for now, and it looks like we want to go true, false, false, false. And we'll see what happens there. And there we go. That's our next connection. Now we need to do our third connection, which is going to be, it'll be in this next branch here. And so this one is between item 1 and item 3. So we're going to go, okay, we'll change this to the next index. Let's try 1 and 3. And no, that doesn't quite look like it's worked. Let me just preview this off because it's getting in the way for me. What is that doing? Alright, because we've still got this cull pattern on. Let me see if we do get... Oh wow, that is really difficult to tell what's going on. But it looks like we're connecting the wrong ones. So we'll try swap this around. We'll go 3 and 1. Okay, and somewhere in there we are getting the correct one. Bit difficult to tell which one it is, but let's see. No, it's still doing something a bit weird. Let me see if I can figure out what's going on there. So we're connecting 3 to 5. Let's see what happens if we shift this list. Oh no. Hold on. It would seem as if some of them are working, but some of them are not. Maybe we just need to look at our cull pattern. Yes, so this time we're getting... Okay, I see what the problem is. Okay, so it looks like this time our pattern is going to be true, false, 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 false. Or is it? Nope, not quite. Oh, okay. This is probably because I flattened my data structure here. And so we are going to get some weird sort of issues. What I will start by doing is pruning this tree. So anything with less than 2, and then now we have, what do we have? Let's try true, false, false. There we go. So that's that is what we now want. We should have everything connecting up properly. And okay, I can see that this might be an issue when I am now trying to merge these faces together. So what I will need to do is I'll need to make sure I'm doing this same thing here. What we are going to want to do, we're not going to want to flatten that input. We're going to want to cull individual trees. So what we are going to do is we're going to plug this into a tree statistics component, and we're going to use a cull pattern, and we're basically going to cull individual tree branches, and then we're going to retrieve. Okay, so this will take all the correct branches that we want, and then all we need to do is just retrieve that exact branch using a tree branch component. So we grab the tree coming out of our prune, and then this here. Alright, so next, okay, I'll just do that for all of my data sets. So let's see, we're going to prune anything with less than 2, and we might need to fix our cull pattern again. This should just be true, false. Yep. Okay, so once again, we'll just make a copy of this. Let me get rid of that. Make a copy of this. Tree statistics, tree branch, and true, false. Let me give myself some more space here. And we're going to do the same thing over here. And so this one we won't be able to prune because every item will have, because we wrap the paths around, everything will have 2 items in its list. So we're going to go tree statistics, plug that into our path, and then our cull pattern. And there we go. Can get rid of that and slide that right up. Alright, so now we have our matching points. And the reason I wanted to do these as points was just so that, with the polyline it's a really easy way to preview what's going on. But what we actually need are the faces. So we're going to graft these faces coming in here. And we're going to make sure our data structure still lines up. Yep. And then we're going to take everything out of our face normals and plug that in there, except for that. And then what we're going to do is we are going to, okay, now that we've got, let me just turn this off. Okay, so now we should have a collection of 2 faces in each of these lists that will match up with each other. So what we need to do is we need to find a way to join them together. And what we can do is we can use a mesh from points component. The way we do that is we deconstruct these meshes here, and then we're going to shift the paths back 1 index, and then we're going to use mesh from points. And so this is our collection of points. We can plug in static numbers over here, so I'm going to use 4 and 2. I know that these are 4 and 2 because the quad face has 4 items and there are 2 quad faces each. So let's see, we'll plug that into there and that into there, and we do get a slight issue. Let's try the other way. 2 and 4. Now that is slightly better, but at the same time we are still getting an issue, and that's because the alignment of these faces is not necessarily correct. So what we need to do is, out of this tree branch, we need to take a list item, and then we need I and I plus 1, and then we need to deconstruct this mesh as well. But I believe we need to reverse the list, and then we also need to shift the list. Actually, let's just see what happens if we reverse it. We'll simplify it here so that our structure is going to match up. And yep, that's almost right. And we're just going to shift it 2. And then instead of plugging that in there, we'll just make sure that our data structure hasn't changed, but it has. So we're going to simplify again, and we'll plug that in. And there we go. We are now getting matching sort of, how should we say? We're getting matching blocks. And the last thing we need to do is these aren't closed properly because we've plugged 4 items in, and we need 5 points in order to close this shape. So what we do need to do is repeat the data here up to a list length of 5. Same thing here, and then plug those in. And I need to change this to 5. Alright, there we go. So we don't need to do that too many more times. We should just be able to copy and paste this, more or less. Actually, okay, so let's see what happens when we copy and paste this. Yep, that lines up pretty well. And we'll do the same thing here. That one lines up pretty well as well. And now what we can do is, let's just turn all of this off. We can join these up using WB join. This is a Weaverbird component. If you don't have Weaverbird, get Weaverbird. It is very useful. Cool, so now we're going to flatten these and turn these off. And now you'll notice that we do have some holes in our mesh. So this is the last part of the definition. We need to find all of these corresponding holes. And the way we're going to do that is we're basically going to go out and do mass list iteming out. So let's see, from my mesh explode, what we do want to do is we want to ignore anything in the center. So what I am going to do is I'm going to do a cull index. Actually, no, I won't do I'll do a list item, sorry. And the item is going to be, actually, I'm going to set multiple items because I want 0 and -1. And then we're going to plug that in there. Ooh, okay. We might want these pieces of geometry here. So we can see we're getting those end ones. And now what we're also going to want to do, here we're going to want to do a cull index. And actually before we do that, we're going to want to flip these matrices because they aren't going to line up properly. We've got 4 branches per each plane, each with 2 items, when in reality what we want is to split these up into this is one list and this is one list. So here we're going to grab our path mapper, the super fantastic component, and we're going to create our null mapping, check our data structure. So we want to go from ABI to AI, and we'll check that. Yep, that's what we want. And so now from here, oops, we are going to cull 0 and -1, and that'll give us the middle 2 items. And then we're also going to list item out. Let me see. We'll just set this to 0. So that's going to give us those 2 items. We're also going to want, let me see, we're also going to need the items on this side. And so the way we're going to grab those is by flipping the matrix again. And list iteming out. Actually, yep, we want to do that. And then we're going to grab our cull index. Actually, rather than doing that, let me see, if I've got these items here, and I've got, let me see, these items here, mesh, 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 oops. What we do want to do is we want to take these faces here and these faces here. So maybe I don't actually want to flip those around. If those stay in sets of 2, does that help me? No, I need to flip them around. Because what we now need to do is we need to explode the mesh, and we need to extract a certain set of faces. So I'm going to list item out. I'm not sure which one at the moment, so I can turn my point list on, and I can see that I want, ooh, where are we looking? That looks like item 2. Let me just see. Okay, so those are the 4 faces that I want there, except we are getting the ones in the middle as well. So let me see what I can do to remedy that. What we might want to do is, let's see. Yeah, okay. That'll be all of those faces, except we're going to need to list item these out separately. Sorry, this is getting a bit messy now. I'm going to set this to item 0, and then we need -1. So this will be these faces over here, and then for our bottom we want item number 4. So we'll do the same thing, and we'll just change our item index to 4. Cool, so that's working. And then we just need to grab the faces on these sides as well. And so let's see what we can do. If we list item out these, we should get, yep, we're getting one side and the other side. And so now we just need to explode the meshes, and we need to get our corresponding faces. So we need, what is that? Is that face 3 and face 1? Let's see which ones we want. Turn these off. Let's try 3. Yep. And did I say 1? Coming from there. And there we go. So that should be all the face geometry we need. Let's see what happens when we try and join them all up together. So I'm going to join these separately, and we might see why I did that in a sec if my hunch is correct. I'm going to turn this off, and I'm going to flatten that output as well, and then we're going to do another WB join. And then we're going to weld our vertices together. And now if I bake this out, yes, so you can see we are getting some normal issues where these ones are facing out properly and these ones are facing the wrong way. And so this is what sometimes happens with meshes. If your normals aren't all facing the same direction, you're going to get this weird sort of scenario where you can half see inside your mesh and half not at the same time. It's quite an annoying issue. There is a mesh unify normals component, but I would much, because I've got these in separate lists, I should quite simply be able to flip one of these around and get it to face the right way. And I have the feeling that I'm going to need to flip these ones, because these ones were already facing out when they were constructed. So if I replace this item here with this one, turn that off, delete that, and then bake that out, there we go. There is our shape. And now I can just put this through a Catmull-Clark subdivision and we'll be away laughing. And I could bump this up to 3 subdivisions. And there we go. If you what is quite nice is that if you have the kangaroo component, it has this component called quad divide. So we'll plug that in, and I'm going to set my divisions to a maximum value of 5. But what this does is it basically it subdivides the mesh without smoothing it at all, so that you can sort of harden up your edges. I'll do a preview of this. So I'll bake this input here, and then move that across, and then I'll plug this one in here and bake it too, and then preview it off, and you should see we're getting these much harder edges, and that's because we've got this extra layer of support. If I just move these across, yeah, I'll set this to shaded. We've got this extra layer of support edges along the entire span, and so that helps just give us a bit more shape to our mesh. So cool, so this has been my tutorial on how to create this weird sort of twisted plain box network thing, which I think looks pretty cool. We also looked at the path mapper as well as using the relative item component and a whole lot of other list functionality and stuff. Hope you enjoyed it.